Today, we're going to decode the 2 secret rules that basically govern everything you see. Seriously, from your own reflection to the screen you're looking at right now, it all comes down to a couple of really simple ideas about light. So, let's dive in.
So, let's start with the big one. How do we actually see? How does all this stuff out there get inside our heads? You'd think it would be this incredibly complicated process, but the physics behind it, well, it's surprisingly simple.
Believe it or not, it all boils down to just 2 fundamental rules that light always follows. And once you get these 2, you'll understand the secret behind mirrors, cameras, and even the very eyes you're using to watch this.
Okay, rule number 1, the most basic thing light does, it bounces. I mean, think about it. Most things don't make their own light, right? Your desk isn't glowing. You see it because light from a lamp hits it and then bounces into your eyes. We call this reflection. Now here's the cool part. This bouncing isn't just random. Nope, it follows a very precise law. The angle that a ray of light hits a surface is exactly the same as the angle that it bounces off. It's simple, it's elegant, and it's totally predictable. On a totally flat mirror, this law gives you that perfect, flipped image of yourself. We all know that. But what happens if we start to bend that flat surface? Well, that's when things start to get really fun. And honestly, the best way to picture this is with something you probably have in your kitchen right now. A big, shiny spoon. It's the perfect, everyday example of 2 different kinds of curved mirrors, all in one handy object. So, just think about the 2 sides of that spoon. You've got the inside, the part that would hold soup, right? It curves inward like a little cave. That's a concave mirror. Then you flip it over, and you've got the back that bulges out. That's a convex mirror. Same spoon, 2 completely different ways of bouncing light. That concave side, the inside of the spoon, has this incredible superpower. It takes all the parallel rays of light that hit it and focuses them all down to a single, powerful point. This is literally how you can use a curved mirror to focus sunlight and set a piece of paper on fire. And this focusing power is what creates those really weird reflections. When you're far away from the spoon, you look tiny and upside down. As you move closer, you hit this weird spot where you're the same size but you're still inverted. But then, get really, really close, and bam, you suddenly flip right side up and become gigantic. That's the exact principle behind every makeup or shaving mirror. Okay, so that's rule 1. Light bounces. Got it. But what happens when light doesn't bounce? What if it passes right through something, like from the air into a glass of water? Well, that brings us to rule number 2. Light bends. You've definitely seen this before. You put a straw or a pencil in a glass of water, and it looks like it's snapped right at the surface. It looks broken. That's not just an optical illusion, my friends. That is the second rule of light in action. It's called refraction. Refraction is just the fancy word for light bending when it crosses from one material into another. And why does it bend? It's actually really simple. It's because light travels at different speeds in different things. It goes fastest in a vacuum, a little bit slower in air, and a lot slower in water or glass. Let's just follow a single ray of light for a second. As it enters this block of glass, it slows down, and it bends towards this imaginary line we call the normal. Then, when it pops out the other side and goes back into the air, it speeds up again, and it bends away from the normal. It perfectly reverses what it did on the way in. And here is the big so what. This predictable, reliable bending, this is the secret behind every single lens ever created. From a cheap magnifying glass to the lens in the Hubble Space Telescope. And just like with mirrors, we've really only got 2 main types of lenses. You've got your convex lens, which is fatter in the middle, and it brings light together. It converges it. And then you have the concave lens, which is thinner in the middle, and it spreads light out. It diverges it. You can see it perfectly here. The convex lens takes all those parallel light rays and bends them inwards so they meet at one single point. The concave lens does the exact opposite. It takes those rays and spreads them out so it looks like they're coming from a single point behind the lens. Converging versus diverging. That's the game. So, okay, let's put it all together. Light bounces and light bends. That's it. Those are the 2 rules. And just by getting really, really good at controlling them, we have been able to build technologies that have completely reshaped our world. By mastering the bounce, we use those concave mirrors to make the incredibly powerful, focused beams in our car headlights. We use them to get that magnified view in a shaving mirror. Heck, we can build giant solar furnaces with them.
And on the flip side, we use convex mirrors to get that super wide-angle view in our car's side mirrors to see everything around us.
And what about mastering the bend? Oh man, that unlocks a whole new level. We're talking about cameras to capture our memories, telescopes that let us see across the universe, microscopes that reveal the building blocks of life, and maybe most personally, the eyeglasses that let millions of us see the world with perfect clarity.
And here's where it becomes really personal for so many of us. If you wear glasses, your prescription is measured in something called diopters. Well, that number isn't just some code. It's a precise measurement of the lens's power. Literally, how much it needs to bend the light so it focuses perfectly on your retina. That's physics, custom-made for your face.
In the end, it is just kind of amazing to think that everything, from the silly reflection you see in a spoon to the breathtaking images from a space telescope, it all comes back to two fundamental truths: light bounces and light bends.
Which really just leaves us with one final thought. We have built our entire visual world on mastering these two simple rules. The question is, what's the third rule we haven't discovered yet? What will we learn to control next?